happy. Thank you, Prasenjit. My name is Christo Whittle. I'm from the Council for Scientific and Industrial Research in South Africa. And unlike the previous talks, who's been about orbits and instruments in space and actually producing the products, I'm coming from the end user side. How do we want to utilize the products and how are we going to use it for societal benefit to make an impact with what we're producing over here? So just a little bit about who the CSIR is. We were established in 1945 through Act of Parliament, so we're an arm of government, but some of our funding only is derived from government. Most of our funding is derived from public and private funding. Our core mandate is to produce cutting-edge scientific research and technological innovation to respond to socioeconomic needs and prosperity, to accelerate industry essentially. And of course, contribute towards a capable state, the management of society. So I've just covered this slide about who we are and kind of the role we try to play in South African society. And moving along, it's quite a big organization. We divide it into 9 clusters and aim to have an impact in production, mining, defense and security, advanced agriculture, food security, health, mobility, natural resources, and governance. These are all individual clusters that are divided into impact areas and research groups. I'm in a coastal systems and Earth observation research group, part of the environmental resources impact area, and within smart places. So because of the diversity of the organization, we were the natural entity to choose to lead the development of the South African Oceans and Coastal Information Management System. And this was initiated by different arms of government, the Department of Environmental Affairs, Forestry, Fisheries and Environment, the Department of Science and Innovation. And as part of a government impetus to produce Operation Pakisa, an action plan endorsed by the South African Cabinet. So it's a nationally funded program. It's got a long-term horizon. So there's scope to develop a really well-established project. So during phase 1, we developed interface software infrastructure, and this required the input from several different groups, not just smart places, but also next gen, because the researchers, marine scientists reside in smart places, and then we had the technical development associated with the front face and acquiring the data and implementing the algorithms developed during research. During phase 2, we are also attracting other partners. SCION and SOARS are providing information around hydrodynamic modeling and atmospheric modeling and incorporating our data into that so that we can move from just providing near real-time or hindcasts to also providing predictive modeling sense. So this slide gives kind of an overall picture of how we want to incorporate satellite data with in-situ data and also lab data, combine it with models to influence planning, decision-making to address needs regarding coastal management, search and rescue at sea also, compliance enforcement, and also disaster management. So this translates not just on a national scale, but also a regional scale. So our involvement in this project kind of laid the groundwork for then becoming a partner in African Union GMS in Africa program and leading the project called Marcosia, Marine and Coastal Operations for Southern Africa and the Indian Ocean. So now we have partners in 8 countries in Southern Africa, including Madagascar and Mauritius. And then within these countries, 12 partners combining expertise, using regional knowledge, then to produce tailored products for their regions as well through these interfaces. So during phase 1, we kind of copied things from OSIMS and then incorporated new information from our partners. But in phase 2, what we really need to do now is consolidate this platform and increase the reliability and the uptime so that we can ensure that users get regular use out of it so that we can also introduce it into policy frameworks and so on. So the whole drive behind this Marcosia project is underscored by these 6 pillars. We want to address existing policies that are being promulgated by the different governments and get this kind of embedded within institutional frameworks from a municipal level to regional, provincial, national, and so on. And then develop these services. As you can see on your right, we've got like 3 services: fisheries and aquaculture, coastal service, marine and maritime. And then I talked about how we would be sharing the knowledge to develop these services. And in that process, there's some capacity building involved, not just at a tertiary level, but also at an institutional level, managers and so on, at different spheres of government. And then promoting outreach, uptake and dissemination, which is part of phase 2, really, where we would be going on roadshows to introduce this kind of information to different municipalities and national and provincial governments. So this whole process requires a co-design, and whereas we are quite familiar with the products that either we produce or we source from CMEMS, as was said earlier by Andrea, and during this project we make extensive use of data from CMEMS, and we understand what we want to see and the kind of analytics that we want out of it. It is not exactly what end users that we are trying to reach with these products to make social impact want to see, not necessarily at all. When you compare what we produce for our interpretation on websites and so on, what is regularly consumed on apps by social media users, which is what many people use who are not specialists, it can look quite different, and it's not the way they want information represented. So what we have to do is interface with really the end users in different spheres, from subsistence fishermen, which is the picture that you see on my left, your left as well, right? Explaining what the data is, what it looks like, and then adjusting it to the way they want to see it, presenting it to them in that format, and then being able to reach them in a way that is easily accessible. Data costs are huge. If you can have a thin vanilla, very thin slice of image sending to someone that just fills up that cell phone so they can make an informed decision about going out to sea and what's happening within the marine climate, that's what they need. On the other hand, we also work with the sea rescue services, incorporated their methods and accelerated by developing a tool so that they can just input coordinates, and then the tool will grab modeled information together with their coefficients that they use to calculate leeway drift to be able to track persons and objects lost at sea. So the services, I'm just going to skip through them without discussing them in detail because we're going to run out of time, but I wanted to just run through so you can see. We have a fisheries service, and I'll just highlight the ones where sea surface temperature data and data from GHRSST and CMEMS plays a role. In terms of the fisheries services, going out to sea, knowing what is happening with the water conditions, what the upwelling is, where the potential fishing zones are in terms of the fronts, this is where the small SST images that I was talking about are sent to cell phones in this very specific app in a partnership with an NGO that addresses the needs of subsistence fishermen. This is then also used. This is an example of the app. This is the kind of images that they get on it, downloading it, and the NGO partner is called Abelobi. So over here you can see the sea surface temperature images, and of course the one on the top is a chlorophyll A concentration image to give us warnings regarding HABs. Okay. Then there's also aquaculture requiring a similar service. Marine heat waves, we'll be talking about that on Thursday, will also affect the quality of the water that's coming into the intake on the land-based aquaculture farms for abalone around our coast, and cause stress to the animals, and that needs to be monitored. It's also precursors for HAB conditions, same kind of thing. So again, the sea surface temperature important in this regard. This is some more of that. This service can be translated onto the West Coast, but also, of course, in Tanzania, where we're looking for potential fishing zones. This will also be useful. Data we're using is ALCHI and SLSTR from Sentinel-3, but also Ostia was also producing anomalies. And in the coral bleaching product, similar to NOAA Coast Watch on the east coast of Africa. So it's also based on CMEMS Ostia data and also producing anomalies. The red dots are particular monitoring points where you can go and interrogate the data, generate the time series, analytics, and it's also based on the information that the managers in Kenya were already using to monitor the coral bleaching. All we do is made it easier and facilitated using this spatial coral bleaching product. Okay, coastal ecosystems. Quite recently, we had a storm surge event, quite a substantial storm surge event in Cape Town, where we had a combination of a new moon and quite a big subtropical cyclone approaching, with waves reaching up to 6 meters near the coast. And we had a huge storm surge event putting water right up into our beaches and into like established like a neighborhood, in Falls Bay. And firstly, having SAWS on board, South African Weather Service, to be able to predict and monitor the event and the possibility of the event occurring, but then also in the aftermath, managing what has happened and the erosion that occurred on the beaches with regard to being able to have high-res images to follow this kind of event. And coastal ecosystems, so I'm going to skip across this. This is part of our security, traffic monitoring, looking at unregulated fishing, and this is some successes with the sea rescue and the fishing. But I wanted to get to the sea rescue. So one of the, you'd wonder why would the sea surface temperature be important? So for the sea rescue, well, one of the things is like how long a possible victim overboard would be exposed to the very cold conditions, right? And then also, not only that, because we're adding a layer of the wind from source to help predict the drift from the leeway after the object or person has been overboard and see where they're going to, we're also adding a layer of current. Having accurate currents requires high resolution models, which need to be validated. And here you need highly accurate, high resolution sea surface temperature to validate the surface expression of the models. If you are getting incorrect data to validate the model with, you would also end up with an incorrect product, being able to trace what's happening. And then this is an example of the interface. It kind of, we're working on it to look better. We're also going to add a layer of drift so we can get probability. So in summary, the Marine Services developing oceans and Marcosio are demonstrating a national and a regional impact, improving ecosystem management, EEZ security, and the support of economic activities, and especially making a difference from a level right from subsistence into a municipal level. So subsistence level is where we'll be managing harmful algal blooms, giving forecasts of potential fishing zones. On a municipal level is when you have the impact of the harmful algal bloom, which causes crayfish walkouts on our west coast, and being able to predict the presence of the bloom and then be able to prepare a response takes some time. So once you know the bloom is there, you notify the municipality. They then notify various actors in their sphere to be able to respond, to redeposit that resource back into the ocean beyond the influence of the low oxygen water, things like that. So the data products developed by the science team members play a crucial role in delivering several of the services. I've mentioned the fisheries, aquaculture, coral bleaching, and sea rescue. I think it's going to be vital in developing the high resolution models that we want to do and being able to test the validity of those models, and also for assimilation. Current priority, reliable service, negligible downtime, and incorporating this into institutional frameworks at different spheres of governance. And then lastly, adding some analytics for looking at getting a historical perspective so we can do some longer term planning for mitigation and not just being reactive with near real-time information. Thank you. Yeah.